guys, welcome back. Today we are going to focus our energy on how to find the domain of a rational expression or a rational function. So let's do this. So rational expression, what is that? So fancy math, a rational expression is pretty much a quotient of two polynomials. Okay, so p of x and q of x. What is a rational function? I'm going to tell you right now, what is a rational function? A rational function is also a quotient of two polynomials, but the difference is that we will use function notation. So p of x over q of x. So in semi-English, rational expression is a quotient of two polynomials. So like in this case, what if we just toss in x plus 1 over x plus 2? What is a rational function? It's a function. And what's so special about that function? Well, you guessed it, it's a quotient of two polynomials. So like in English, a rational expression, it's like a fraction. Cool. Okay. But a formal definition is a quotient of two polynomials. Today we are going to focus on energy on what the title suggests, how to find the domain of a rational expression or function. Now, we have talked about how to find the domains of functions. If the function was given in the graph form, then we're like, oh, okay, look, the domain is this. If the function was given as a set of ordered pairs, then we just listed all the input values or all the x values. But the question is, oh, I wrote this wrong. So let me just scratch this off. Put f of x equals. My apologies. Okay. But the question is, what if we are not given a graph? What if we're not given a set of ordered pairs? What if we're just given a function and we are asked to identify the domain? Okay, since a graph or a set of ordered pairs is not provided, we're going to find the domain by the following. So the domain is given by all the x values or all the acceptable x values. Okay. If you have a rational expression or rational function, I need you to bear in mind that division by 0 is not defined. So whatever happens, we need to make sure that the denominator doesn't equal to 0. So first we want to identify the restriction or the restrictions on the variable. So I want to know what makes the denominator equal to 0. So let's just say for fake extra credit, we want to find the domain of this function. Okay. How do I find the domain? So I'm like, what are the acceptable x values? So I'm like, okay, I guess I can use any x value except for those that make the denominator 0. So I want to know what are the restrictions on the variable. Okay, restrictions, the restriction or restrictions on the variable. The restrictions on the variable are the values that make the denominator equal to 0. So we're going to take the denominator. I don't have a lot of space, so I'm going to use my made-up abbreviation. Remember, made-up abbreviations are fine as long as you're not using them to define the variable or write your answer in a sentence. To find the restrictions on the variable, or to find what the variable cannot equal, you're going to take the denominator and set that equal to 0. So in this case, our denominator is x plus 2. And we want to set that equal to 0. Okay, when we set that equal to 0, after we subtract 2 from both sides, that will give us x equals negative 2. Now, what is the problem when x equals negative 2? I'm going to focus on the denominator, but you could plug it into the top for all I care. Okay, when x equals negative 2, negative 2 plus 2 is 0. And guess what? Something over 0 is undefined. So we want to tell the world x could equal anything except for negative 2. So we have x does not equal negative 2. When I use this symbol, it's not equal to in conjunction with domain or in conjunction with the word restriction, I'll read it as can't equal. Okay, so we have x can't equal 2. So what is the domain? The domain is pretty much all real numbers except for negative 2. Now we don't have directions right here because this is a bonus problem that I made up on the spot. But suppose it says find the domain of the rational function and then write the domain in interval notation. I can give the domain in verbal form, the domain, everything except for negative 2, but that's not an interval notation. Now, if you're a genius and you're like, I got this, I know how to write this in interval notation, I know how to express in interval notation all real numbers except for -2, then go for it. But you know the drill. You're not going to take the test from me, so I'm going to show you my thought process. So what is the domain? I'm going to go ahead and write some words. The domain is going to be all real numbers except for -2. So I'm going to take some space from our exercise area. So what am I going to do? I'm going to graph the entire real number line with the exception of -2. So we're going to do a line, highlight a number on it, instant number line. We want to graph everything except for -2. So we're going to do an open circle on -2, and then we're going to graph everything else. And thanks to this optional graph, with confidence, I will write the domain in interval notation. So in interval notation, we have that the domain is given by the interval from -infinity to -2, where -2 is excluded. We have another piece, so we're going to use the union symbol. Remember, we use the union symbol with interval notation, or it doesn't look too cute. The second interval, union, from -2 to infinity, where -2 is excluded. So -2 to infinity. And this is how we would have to write the domain. Why? Because we are asked to write it in interval notation. Okay, so to find the domain of a rational expression or function, first things first, I need you to find the restriction or restrictions on the variable. What is that? That is code for tell me what the variable cannot equal. In order to find the restrictions on the variable, you're going to take the denominator, set that equal to 0. What will be your domain? Your domain will then be the set of all real numbers except for whatever that restriction you found, and then you go straight to interval notation. Whether you see it right away, or if you're like me, you do the graph and then spit out the answer in interval notation. Okay, so for fun problem number 1, it's only one set of problems. We're going to do 4 problems and then we're out. So I guess this was our 5th problem, but we're going to do 4 problems and we're out. So it says problem A, the directions. Find the domain of each rational function. Write the domain in interval notation. So rational function, that's just code for like we got a fraction, okay, quotient of 2 polynomials. So I'm like, oh man, I got a rational function. What is the domain? Oh, all real numbers except for those that make the denominator equal to 0. So let's go ahead and identify the restrictions. Okay, tell me what the variable cannot equal. So we're going to take that denominator and set that equal to 0. I know you can do things in your head, but I can't, so I will always show my work. So again, to find the domain of a rational function, we want to first identify the restrictions on the variable. Tell me what the variable cannot equal. When you take the denominator and set that equal to 0, we're going to subtract 7 from both sides, and that will leave you with 2x is equal to -7. Okay, to finish it off, to get rid of the times 2, let's go ahead, divide both sides by 2, and that will give us x equals -7/2. Okay, so what is the moral of the story? The domain is given by the set of all real numbers with the exception of -7/2. Okay, so if you don't like that symbol, remind me not to use it again. Okay, all real numbers. I make it clear to the students that I don't want to see hieroglyphics or this pound sign, but in this case I'm not submitting these words for credit. I'm not submitting these words as the answer. I want to point that out, so I'm going to use my made-up abbreviation. So the domain is given by the set of all real numbers with the exception of this restriction, with the exception of this number that makes the denominator equal to 0. So now let's go ahead and write this in interval notation. If you want to go straight to interval notation, go for it, but you know my speech. It's really hard for me to go straight to interval notation. So what am I going to do? I'm going to graph the entire number line with the exception of -7/2, -3.5, -3.5, however you see it. Okay, I'm just going to keep the improper fraction. So the domain is the set of all real numbers with the exception of -7/2. So let's go ahead and earn our full credit. So we have 2 pieces in this for the interval notation. Piece 1, we have the interval from -7/2 to say that again. We have the interval from -infinity to -7/2, -infinity to -7/2, where -7/2 is excluded, or in union, interval from -7/2 to +infinity, where -7/2 is still excluded. Okay, so that is our first problem. Let's go ahead and knock out our second problem. Problem B. Where are we? Okay, so problem B, we have that f of x is equal to 3x plus 1 over x squared minus 3x plus 4. F of x is equal to 3x plus 1 over x squared minus 3x plus 4. Okay, fantastic. So the directions, find the domain of each rational function. So rational function or fraction. I'm like, okay, what's the domain? Oh, it's all real numbers except for the restrictions. All real numbers except for those that make the denominator equal to 0. Okay, if you want to know what makes the denominator equal to 0, then you're going to take that denominator and set that equal to 0. Okay, so I want to know what makes the denominator equal to 0. Okay, so let's go ahead, take that denominator, set that equal to 0, and then solve this equation however you can. Okay, so we have a degree 2 equation, a quadratic equation. We're going to solve by factoring. Okay, first things first, set it equal to 0. Done. Second step, factor completely. Prereq, watch out for common factors. The terms don't have any factors in common other than 1. Trinomial, is the leading coefficient 1? It sure is. So let's do this. If the leading coefficient is 1, then we don't have to use the AC method. But if you love that method, then go for it. So let's go ahead, throw down parentheses. Focus on getting the product of the first terms. The product of the first term should give us x squared, so we will use variable times itself. To complete the binomial factors, we want factors of c that add up to b. Factors of 4 that add up to -3. I think that's a negative because I can't see with my circle. Then that factors of 4 that add up to -3 are going to be 1 and 4, where both 1 and 4 are negative. So let's check it. I lied to you. Did I write this wrong? I think I copied it wrong. Yeah, I copied it wrong. Oh, because it's not factorable. Okay, so scratch that. I'm not going to rewind this video. So this plus, it's a lie. It should be minus. This is not a subtraction sign. Okay, it doesn't look like it. So let me just write down what it should read. X squared minus 3x minus 4. There's no way to fix it. Okay. Sorry guys, I need to proofread my problems. Okay, so yeah, because I couldn't see the circle got in my way. Okay, there's no excuse. Okay, so I think I'm gonna do the x game because of this technical difficulty. Okay, so corresponding x game, we want factors of c that add up to b. Okay, yeah, so factors of -4 that add up to -3. I learned my lesson. I'm not gonna be that cocky anymore. Okay, so it's gonna be 4 and 1, where larger factor is negative. I'm going to check my answer before I put it in the binomial factors. Product of -4 and 1 is -4. Sum of -4 and 1 is -3. Okay, so we checked it. Let's go ahead, update it. So one side number is -4. So one binomial should read x minus 4. The other side number is +1. So the other binomial should read x plus 1. Okay, it would be nice if I wrote the problem correctly. It happens. Okay. Alright, coming to our problem. Product equals 0, so one of these factors will have to equal 0. Either the first factor equals 0 or the second factor equals 0. So if the first factor equals 0, that's going to lead to a solution of -1. If the second factor equals 0, that's going to lead a solution to 4. Now, what is the problem when x equals -1? If x equals -1, you plug it in everywhere, but the denominator is going to give you 0, and quotient by 0 is not defined. Same speech when x equals 4. So what is the domain? So again, I can say it. The domain is going to be everything except for -1 and +4. So the domain is all real numbers with the exception of -1 and let me just put cannot equal, with the exception of -1 and +4. So we want to tell the world the domain is all real numbers except for -1 and 4. And if you can read that statement, or if you can say that statement and then just see the interval, knock yourself out. Go ahead, write it in interval notation. But I sincerely can't, so that's why I'm gonna graph all the elements in the domain. I'm gonna graph the entire number line with the exception of -1 and 4. So -1 and 4 are out. -1 is smaller, so it should appear first on the number line. So we are gonna graph everything with the exception of -1 and +4. So on this number line we have 3 pieces per se, so we're gonna have 3 intervals and then connect them with the union symbol. So the first interval is gonna be all real numbers from -infinity to -1, where -1 is excluded, union. Second piece of the puzzle, all real numbers from -1 to 4, where both endpoints are excluded, union. Third piece of the puzzle, all real numbers from 4 to infinity, where 4 is excluded. Fantastic. So I said we were going to do 4 problems. This is our second problem. So I'll you 2 more. Give me a sec. Okay, so let's go ahead and knock out problem C, then D, and then we're out. Okay, so we are asked to find the domain of this rational function. So I'm like, okay, domain, all acceptable x values. Oh, I got a fraction. What's the domain? Oh, all real numbers except for those that make the denominator equal to 0. So first things first, I want to find the restrictions on the variable. I want to know what makes the denominator equal to 0. So then I'm like, oh, I don't know what makes the denominator equal to 0. So we're going to take that denominator and set that equal to 0 and then solve for a variable. But check it out. We don't have a variable and 26 does not equal 0. Okay, so what I want to point out is this. For this function, there are no restrictions on the variable. No restrictions on the variable. Okay, so normally what do we say for a rational function? The domain is the set of all real numbers except for those that make the denominator equal to 0. The domain is of a rational function is the set of all real numbers except for the restrictions on the variable, except for those that make the denominator equal to 0. But in this case, we don't have restrictions on the variable, so the domain is just a set of all real numbers. Unfortunately, this is not an interval, so we're going to go ahead have to write an interval notation. If you just have it memorized, then go for it, but I don't. We're going to graph the entire number line, so I'm going to put my favorite number, 0, and then we're going to graph the entire number line. Okay, so in interval notation, we have the interval from negative. That looks weird. Okay, in interval notation, we have the interval from negative to positive infinity. Okay, 3 problems down, 1 more to go. So let's do this. Problem D. Where am I? Problem D. Oh, I lost the problem. Okay. Problem D. We have f of x is equal to x plus 5 over 4x squared plus 9. F of x is equal to x plus 5 over x squared plus 9. So remember, the directions read find the domain of each rational function. So I'm like, domain, all acceptable x values. So I'm like, oh, I have a fraction. What's the domain? Oh, domain, everything except for the restrictions on the variable. Everything except for the values that make the denominator equal to 0. So let's go ahead, take that denominator and set that equal to 0 and then solve for our variable, namely x. Binomial plus, we're going to go straight to sum of cubes. It's not sum of cubes. So in this case, it's not factorable. So in this case, we're going to use the square root method. Use square root method. Okay, we're going to use the square root method to solve the quadratic equation. So let's go ahead, isolate the squared part. We're going to go ahead, subtract 9 from both sides, and that will leave us with 4x squared is equal to -9. Cool. To finish it off, to get rid of the times 4, let's go ahead, divide both sides by 4, and then that will give us x squared is equal to -9/4. We want to isolate the x, so to get rid of the square, we're going to do the inverse operation. So the inverse operation of squaring is square rooting. So let's go ahead, square root both sides and then insert our plus or minus. So on the left side, the square and the square root undo each other, and that will leave us with x equals positive or negative, whatever the square root of negative 9/4 simplifies to. Now, this is the thing. What is the domain of a rational function? The domain would be all real numbers with the exception of the restrictions on the variable, except for whatever makes the denominator equal to 0. Square root of negative 9/4, together we have not discussed how to simplify that, but what I want to point out is that the square root of a negative number is not a real number. Okay, the square root of negative 9/4 is simplifies to a non-real number. So what is the domain? It's all real numbers except for, going back to an earlier problem, we will say all real numbers except for the restrictions on the variable, except for whatever makes the denominator equal to 0. For this funny problem, there's no real number that will make the denominator equal to 0. So in this case, the domain is all real numbers, and we're not going to say except for that non-real number. Okay, the domain is just all real numbers once again. Why? Because there's not a real number that will make the denominator equal to 0. So let's go ahead, write that in interval notation. We're going to just copy it from above. Okay, in interval notation, the set of real numbers is given by the interval from negative to positive infinity. Okay guys, so that's my time and we're out. Thanks.